I'm now going to be doing page 455, number 52. Making auto parts. How many axles would you need for this need to sample if you wanted the standard deviation of the sampling distribution of mean to be 0.005 millimeters? Justify your answer only means show your work. So we know our standard deviation. We want it to be 0.0005. We know that the standard deviation from number 50 is 0.002, divided by the square root of n. In 50 it was 4, but now we don't know what it is. Now we have to use algebra. We use algebra to solve this. So what I'm going to do right now is I'm going to multiply by the square root of n and multiply by the square root of n. I now have the square root of n times 0.0005 is equal to 0.002. And I just rearranged the left side of the equation, now became the right, just my thinking. I need to solve for n, so I need to divide by 0.0005, divide by 0.0005. I then get I get 4. Okay, so now I have a new page. The square root of n is equal to 4. I need to solve for n, the opposite of a square root. Oopsie. Oops, sorry guys. Is a square. And I get n is equal to 16. I'm going to keep going because that only took me 2 minutes, and I'm going to move on to number 59. Okay, songs on an iPod, excuse me. It says explain in part A, explain why you cannot safely calculate probability that the mean playtime X bar is more than 4 minutes for an SRS of 10 songs. There's a reason why we can't do that for an SRS of 10 songs, because n is not greater than or equal to 30. And by the central limit theorem, we need it to be greater than or equal to 30 if it doesn't come from a normal population, okay? Next, part B says, suppose we take an SRS of 36 songs instead. Explain how the central limit theorem allows us to find the probability that the mean playtime is more than 240 seconds. If you think about our penny distribution, the population of pennies looked like this. We then took a sample of up to 30 pennies, and we plotted the sampling distribution. When we plotted the sampling distribution of the averages, it turned out normal. And this is the sampling distribution, not the population. So that's why we can use the normal distribution. Now we have to calculate the probability and show your work. You do have to check all of your conditions. I'll put the no step first. Oops, I'm doing that again, sorry. 1, no is the probability that X bar is greater than 240 for 36 songs. Check your conditions. Random, I believe it's stated, independence, and then the normal. I'm going to skip that part for now, just because I went over it so much in class, and I know everyone was listening. And then number 3 is the mechanics. I'm going to do that on the next page. The mean is equal to 225. The standard deviation is equal to 60 divided by the square root of 36, my sample size. I then put 240, X bar is equal to 240. I want to know greater than. When I do sums now, I say Z is equal to 240 minus 225 divided by my standard deviation. Moving to the next page, I then get Z is equal to 1.5. I need to go to my table, I look at the probability in the back and I subtract it from 1. I then get a p-value equal to 0.0668. I can then draw the conclusion, okay? The conclusion says the probability that the mean playtime is more than 240 seconds is about 0.0668 according to the normal model. Rewind and hear that again if you need help with that. Number 68 on page 456 is also a quick problem, so I'm going to just do that as long as I'm taping it on a roll. Number 68 is a multiple choice. It says the number of hours of light bulb burns before failing varies from bulb to bulb. The distribution of burnout times is strongly skewed right, the central limit theorem says. And if you read 68, the answer is D, the average burnout time of a large number of bulbs. So that means if I take a large number of bulbs and I would keep finding them, so I keep doing it over and over, whoopsie, it would end up normal, okay? Or I shouldn't say it would end up normal. Nothing's always concrete in statistics, so I would say it would be about normal. So the best answer is D. And that's all the book questions I've had so far.